So we're going to start on the H1 reflection, and the first question we have here is of course, hopefully you already watched the lesson here, and I might bring that back. I have the notes open over here in case we need them. There are 849 freshmen enrolled at UT. You survey a random sample of 100 freshmen and calculate the average high school GPA for your sample. Use this to answer parts A through D. So what is the population? Well, the population is everyone. All right. Let's see. So based on the information, well, it doesn't really describe population, but we kind of learned that on day one. Population is everyone. So we are trying to infer about the 849 freshmen enrolled at UT. So that's our population. What is a sample? Well, that would be the people you surveyed, so the 100 freshmen you surveyed. What is the parameter? What are we trying to calculate? Average high school GPA. So that would be the true average high school GPA for all the UT freshmen. But our statistic is the one that we're estimating. All right, so let me go ahead. I'm going to submit these so you can check and see how we're doing so far. Looks like we're doing pretty well. All right. The distribution of sample means for specific sample size consists of the following. It includes the sample means for all the possible samples. All right, not for a specific sample, not all the scores in the sample or in the population. It's all the possible different samples, and it's the means for those. As sample mean increases, the expected value of the mean of samples stays constant. It should stay very close to the true value. The mean for a population is 52, and the standard deviation is 12. What standard deviation should we use would we use for the sampling distribution of the mean if we took samples of size 25? So I'm going to look in your packet, and there's a formula right here. Actually, let me go ahead and copy it over to our little notes. So this is the formula that I'm going to copy over here. And this is, we'll say, scratch work for unit H. Hate it when it gets covered like that. Scratch work for unit H reflections. And we're doing the H1 reflections, which is sampling distribution for means. Distributions for means. And let me go ahead, and the question that we're talking about, let me paste it in. Oh, let me paste the other thing in before I forget. The formula, there you are. And the question was, because this is the only one that requires a little bit of math and thinking, the other ones hopefully are pretty straightforward. So part G. So we're going to take this formula right here, okay? And what I'm going to do is I'm going to calculate the new sample mean. So that would be sigma, and it has a little x, and it really has an x bar, but I can't do the bar on Stablet so well. The original standard deviation is 12. The sample size is 25, and we have to do the square root of that. And so that's just 12 divided by 5. Oops, Control C, equals 12 divided by 5, which hopefully is 2.4. All right, I did that in my head, so could be off. I did it kind of fast. Oh, it would help to have an equal sign, wouldn't it? All right, so let's go see if that's an option. Oh, it is 2.4. All right, so the main idea here is that high school stats, scratch work, unit H. All right. The main idea is that your standard deviation gets lower, and it gets lower by the square root of your sample size. So let's go ahead and hit that and hit submit answer. And voila, everything is correct. Yay. Hopefully the math teacher should be able to get it right? Okay. Given that x is a normal variable with mean 734 and standard deviation 145, So this is question 2. So I'm going to go ahead and add it to my scratch work because this one looks like we'll do a little bit of work, not a lot, but a little bit. So this is problem 2. It's being annoying. It wants to auto do things for me. All right, so there's the mean and the standard deviation. Now, what is the probability? So here, this is actually review. So what I was like, oh, are we going to do it for different sample sizes? No, these are for individuals. So it's just for an x. It's not for an x bar. So we want the probability that x is greater than 100. So we'll go to our Stapplet, put 734 and 145 in our normal distribution. And we want the probability that it's greater than 900. So to the right, we're looking for an area, 900. Calculate area. Label my areas on the plot. And you can see there it is. So it's pretty straightforward. Don't we love our Stapplet? Makes life so much easier. My AP Stats students are a little sad that, that they have to use calculators now. Well, it's good for them. They need it. They're not allowed to use calculators on the AP test. So that's what, I mean, not allowed to use Stapplet on the AP test. So they have to learn how to do the calculators. So in this case, we're going to get 0.1261. All right, so that's kind of the idea. I don't think I really need to record notes on the rest of this. So 0.126 between 600 and 700, so that's between two values. And I'm getting 0.2296, which is pretty much 229. That's pretty much it. Top 1% of score. So the value, so that's your hint. We have to switch this to that. And we wanted the top 1%. So my area, you might be tempted to say 0.1. It's 0.01, and it's the top. So we want it on the right. And I'll go ahead and copy this one down because it's a little trickier. And you can see the values 1071.3204. I'll put that there. So this is for part C. And I'll go ahead and copy this problem just so you know what it is. Now, that's part C right there. Okay. And I skipped part B, but that was pretty straightforward. Find C such that 8% of the area under the normal curve lies to the right of C. So remember, when we are doing Z's, what that means is I need a Z distribution, which I changed the mean to 0 and the standard deviation to 1. Hit plot distribution. And they wanted what percent of the curve? 8%. So make sure I do 0.08, and it lies to the right, I think. Yes, lies to the right. Hit calculate, and there it gives me a Z-score, and boom. So notice one thing on the curves on the Stapplets. I'm going to paste this in so you can see it. Oh, come on. Yeah, I thought I copied that. There it is. So let me move this up here. Move this up. All right. So if you look at it, notice how it says Z on the curve. I know it's kind of like, well, Mrs. Overman, that thing's floating over it. I know. It shows Z on the curve, right down there. And it says standard normal distribution. And your center is 0, and then you have 1, 2, 3, and -1, -2, -3. When it says standard normal distribution, you are working in Z-scores. Here you can see it. This is a normal distribution with a mean of 734 and 145. And then you have the actual values here. So keep that in mind. And that should be it. Let's go ahead. Oh, I didn't even do the values. So what was it? Here it's 1.4051 in that area. This is 1071. There's 10, 1.405. That looks like it. And let's submit our answers. Make sure we got all our credit. And we do. So please feel free to share with me something that maybe you struggled with or any questions you might have here. But 10 minutes to go through the homework, not too bad.